Let's learn about XArray and work with some satellite imagery. This notebook will also give you a preview of what the future of Earth observation in Python looks like. We're going to now get data Sentinel-2 satellite imagery for anywhere in the world. We'll get a data cube. We'll stream the data directly from cloud and do some processing very seamlessly. And this shows you how modern remote sensing is evolving around this XArray ecosystem. We're not going to spend too much time on the components of those ecosystem, which is stack and cloud optimized, geotiffin, etc. But you'll get a preview of how that works and how different it is to work with remote sensing data in this ecosystem. To understand how XArray works, first we need to get some data as an XArray dataset. We're going to use a cloud-based service to query for some images and get those images as XArray dataset directly streamed from the cloud. We're not downloading anything locally. We're defining a latitude and longitude. You can pick any location in the world and use the latitude and longitude. You can also replace this with any year. We are going to use the Sentinel-2 data. So Sentinel-2 was launched in 2015. So 2015 to current, you can get imagery for anywhere in the world. This is a pretty high resolution data set, 10 meter per pixel resolution, multispectral data. And we're going to query for the data over this region. So we're going to say, I want imagery captured over this region in 2023. There are many places that host this data. It's an open source data set. This is also hosted on AWS, and there's a Stack server which allows you to query for the data and read the data free of cost. So this is a free service that allows you to query and stream Sentinel-2 data from AWS to any Python library. So we're going to search for this. This is using a standard called Stack, Spatial Temporal Asset Catalog, STAC, which provides you a standard way to query cloud-hosted datasets like this. Here we are saying that we want the Sentinel-2 collection for this bounding box, just creating a small bounding box around this coordinate to make this notebook work in a classroom setting where we don't have much time. We have defined a very small bounding box, so we're going to get maybe around 1 kilometer bounding box around the chosen coordinate, but you can expand it. It will take more time to stream the data, but you can do this later on. So now we're just saying, give me a 1 kilometer region around that coordinate and give me the imagery that was collected over this bounding box, which have less than 30% cloud cover in 2023. And we run this, we get some data. So this will say these are all the images that were matched from the catalog that matched a query, and we can just load it into XArray. So we say, I want to load red, green, blue, and NIR band at 10 meter resolution for this bounding box. And chunks, when you read this data, you don't want to read everything into memory at once. We'll read them as small pieces. It just says use the default chunk size that you want to use. And this Sentinel-2 dataset can have overlaps. You can have multiple imagery that is broken down into tiles. And for the same imagery, you'll have multiple imagery of the same day. Even though it's the same data, you may have multiple tiles. So we just say group by solar day. So you get one image grouped by each day. So you get one image per day from this. And now once you do this, we now get our first look at what an XArray dataset looks like. XArray also gives us really cool visualization of the structure of the data. So if you just give the variable name, it says this DS that we just queried is an XArray dataset. It has got these 3 dimensions, X, Y, and time. And it has got these 4 variables. So we have red, green, and blue, and NIR. These are the bands. We have X and Y coordinates. So these are the lat long values. The projection of Sentinel-2 is UTM, depending on where you are in UTM. So the coordinates you see are UTM coordinates. This is in 32644 UTM projection. Time, we have different time. So you can see this is a data cube of 70 time steps, and X and Y are as many pixels. So you have 182 pixel wide and 202 pixel tall data cube with 70 time steps. And all of this is a single structure. At this point, you can see it's not in our computer. It's just describing what the data would look like once we have this loaded into our notebook. Depending on the size of the data, it may take a while, but once you say ds.compute, it's going to now find all the pixels that match your query and create this data cube for you. So XArray works with cloud-hosted files. So right now, it is not downloading entire files. This is downloading those pixels that are required for your creating your dataset. And you only download and stream the pixels that are needed. If you download entire Sentinel files, they are gigabytes in size. Here we say, I don't want everything. I just want the pixels that are in this region for this year worth of data and only this 4 bands. It's going to fetch all those pixels, load it into the RAM, and we have our XArray data set that we can now work with. While it's computing says it took about 42 seconds. If you have a long running computation in a Jupyter notebook, you can use this cell magic called time, which will tell you how much time it took to execute this cell, just for your reference. So it just took about 42 seconds to stream this data. And now we have this data structure that we can work with and visualize this. We have this XArray data cube that we have. Let's learn about all this different terminology and how to navigate through this, how to query for different parts of it. And then lastly, we'll create a nice composite image and visualize this. So the basic terminology, first, data set in XArray is this multi-dimensional data cube that may include X, Y, time, and different variables. Each of those variables is an array in itself. So if I say I want to only work with one of the bands, for example, I want to do something with the red band. To select a particular variable, you can use the dot syntax. So it's a ds.red that will select the red band. And what you get is the array for the red band. So you can see now our dimensions have reduced by 1. So we now have this array. It was a data set. From that, we selected this variable called red. And the result is a data array with 3 dimensions. So now from a 4-dimensional structure, we now have a 3-dimensional structure. This is important when you're trying to visualize any data, XArray data. You can only visualize 3 dimensions, X, Y, and a variable. You can't visualize 4-dimensional data because it requires a 3D visualization. So then when you're trying to plot something, you'll say, I have too many dimensions, I can't plot it. So make sure you only have, X, Y, and 1 time step. You can't even visualize 70 time step because that'll be a 3-dimensional data. So you'll have to kind of extract and subset the data for visualization for the time step that you want. When you have, so to select a variable, you can use the dot syntax. What about selecting some time step? We have 70 time steps with 70 different images. How do I select one of those images? Similar to pandas, pandas has lock and ilock, locate and index locate. XArray provides you cell, select, and iCell, iSelect. So it allows you to select particular pixels from this array based on the name of those dimensions. We have 70 time step. We can say data.iCell, select by index, time equals -1. A -1 index is the latest one. So this says, show me the latest red band image over this region. So we had this data array with 70 time step. We can now say DA time equals -1. So give me the index -1, which is the last index. And you now have this array, which is a 2-dimensional image of that timestamp of red band. And you could extract that here. How do I get the first image? So I have 70 timestamp. What was the first image? How do I change this code? What do I change here? So if I say time 0, you'll see that this image is 2023, 13 January. So since we requested data for January, 2023, the first image in our stack was collected in 13 January. The next image, if I say time 1, it's an image on 18 January. Sentinel-2 collects images every 5 days. So you can see our stack has this image every 5 days, and we can extract the specific slices of time through that. If we know the value of the time, we can use cell. So index is by index. So you have 70 things, first, second, third, fourth. But if you want to extract images specific time, let's say I want this image, 2023, 118. I can say I know the value of the time. I want to just select this. So if I say cell, I need to give the name of the value. So say I want the image of that particular time. So I can use cell if I know the name or the coordinate value. If I just know the index, I can use iCell. So those two are there depending on what you want to query for. You can use iCell or cell. So let's say we have this array. This is an XArray data array structure. If you want to do some manipulation or say, I just want to print the values, or maybe I'm trying to use the function, I just want the actual values as an array. You can call dot values on any of those arrays and you'll get the actual array. So we'll say, I just called my NumPy array. So if you're working the XArray and say, finally, I just want to extract some array and send it to NumPy or some other function, you can do a query and then call dot values on that. Another thing you can do is you can do queries at multiple dimensions. So you can see I have this 3-dimensional structure. We have time, X and Y coordinates. I have all this array. I can say, give me the latest value for the time. You can also give me the latest value at X and Y. So the last value and X and Y coordinate. So now I get this one value. So this is the pixel value at time step, the last time step at the last X and Y coordinate in the array. So you can query for a specific index or specific value and combine different dimensions in a single query. We have so many dates in our image. We can say, I want to select a particular time. So here we know the value of this particular time. So we can just use cell function. And sometimes we say, let's say I want images on 15th of December. Maybe let's do a value where you don't have an image. So there are times where you don't know where there is a value at that particular coordinate. So you can ask for the value at the near. I think this is the default now. So the default is nearest. So when you ask for something, it'll always give you the nearest value from there. So as you can see, this one has asked for a 10th of December. The nearest value in our array was on 9th of December. So that's what we got. So if you don't know the exact date where the data is or exact coordinate where your data is, you can ask for the value at nearest coordinate. And this will be helpful. For example, there are many climate dataset which are very low resolution. You have values that 23 degrees, 24 degrees, 25 degrees, and you want data at 23.7 degrees. You can say, and you will get an error saying there's no data at 23.7 degrees. I only have data at 23 or 24. So you can just say, give me the nearest one. So the nearest value in your data array. You can also request a range of data. So you say, I want all images in January. You can say, give me all images from range 1st of January to 31st January. And you can now get all images that were collected in January. You can see there were 3 images that were collected in January, and you get data cube of those. So this is some examples of using cell and iCell to query for specific bands, specific coordinates, or specific pixels within the XArray data structure. So if you want to see the metadata, these items, these are individual images. So if I look at these items, these are individual items with all of their properties. This is all the metadata. So stack allows you to query for, say, give me cloud cover less than 30 or some property. I want MGRS style, and it'll give you those images that match that. Okay, my favorite feature of working with XArray is that once you have this multi-dimensional data, you can do the kind of time series processing, which is very hard or impossible in any other library in Python. One of the common things we want to do is each satellite image may have clouds in it. So you take one image, may be cloudy, the next image may have some cloud shadows. And typically when you want to do some analysis, you want to create a cloud-free composite. So you take multiple observations at the same region and you say, give me the median value at each pixel. So I have this, each image, 70 images taken over the year. What is the average value of the pixel at each location? The low values will be cloud shadows, high will be clouds, the median value will be cloud-free. So a typical analysis in remote sensing is to create this median composite. Very hard to do in kind of the old Python ecosystem. XArray, since we have all the structure in a single dataset, we can now aggregate it very easily. So let's say we want to aggregate and create a median composite. We can just say ds.median across time. So we can say, I have this data cube, give me the median value across time. So it'll take each XY value from those time dimension, give me the median value. And if I run this, you'll see that I get my X and Y dataset, which is the image, each pixel, which is median across those 70 time steps. And we could just compute this very fast. This operation went so fast because we are doing those vectorized operations. We're not iterating. In Rasterio, you'll iterate over each image and say, give me all the values at each pixel. I'll average them or median value, and I'll store them in a separate array. Here, you just have everything in RAM. You just say, give me the median value, and you can immediately compute that. So it's really fun working with this kind of time series data. If you're doing any kind of time series aggregation, if you're using Earth Engine, aggregation can be a painful thing. For example, I want to create monthly median composites. Now that's a painful process to do elsewhere. You'll shortly see there's one line of code in XArray. Just say group by month median. That's it. So again, it makes all of this time series analysis so easy and seamless and very fast. So we have our median composite. Let's look at that. We have not visualized this data. We have extracted 70 satellite images. We now have computed the median value at each pixel. That would be a cloud-free visualization. Let's see what that image looks like. XArray comes with its own plotting functions. You can plot a time series and extract some time series values. So for example, you have a data of temperature, you can plot a temperature chart. So you can plot those kind of 2D charts. You can also show images. So if you have arrays, you want to show them, you can use this XArray plot IamShow, which is image show function. If you just do XArray plot, they'll allow you to plot two-dimensional charts, like time series chart and so on. IamShow will render arrays as images. So if you have an array, a two-dimensional array like this, and you want to show, you will use the IamShow function. We now have this data where we have this median array for red, median array for green, median array for blue, and so on. We want to create them, convert it to an array so we can plot it. So XArray provides you with this function called toArray, which will take your data set, which has got multiple variables, will turn those variables into another dimension. So you can extract and plot them easily. So let's call this function toArray, and we'll say we'll name our new dimension that will be created called band. So now you can see we have taken this 4 variables, turned them into bands. So now we have this 3-dimensional data where we have, or 3-dimensional data where we have 4 band variables, 4 band coordinates and X and Y. So now we have this data set that is suitable for plotting. If you want to plot RGB composite, you'll say, I want to select red, green, and blue bands, and then plot them, and we'll give you an RGB image out of that. So before plotting data, we have to convert the data set into an array. Some servers, some static servers will already give you red, green, blue, all of those bands as a dimension. So when you query, you'll directly get lat, long, and bands. Some dataset will give you, some servers will give you those bands as variables. And once you're done with the analysis, you can just convert them into an array using the toArray function. So now we have our array, we can plot that. So we can say, I want to plot 3 bands. You can only plot 3 bands at once. So human eyes can see only 3 colors. We can only see 3 channels. So we can select any 3 of those out of the 4 and say, show me that on this axis. When we plot this by default, it doesn't know what are the minimum and maximum values of those values. So it's going to use the full range of data. So you can say, I don't know what is the range of your input values. You need to give some min-max values. So when you visualize any raster data, you say, what is the range of data that you have in the data? So we'll say my min is 0, max is 3000. Typically, those values are reflectance values. They are between 0 to 0.3, and these are scale values. So our values are typically between 0 to 3000. And now you can see this is the visualization. So this is the median composite image that we created over this coordinate. And we can now visualize this as an RGB. XArray plotting function also has this extra parameter that's, I don't know what are the parameters. I don't know what are the min-max values of this data range. It provides you with this another option called robust true. Similar to how your desktop software visualizes satellite imagery, if you add a new image to QGIS or ArcGIS, it applies a contrast stretch automatically. It'll do 2 to 98 percentile stretch. So it'll figure out what's the value at the bottom 2 percentile, what's the value at the 98 percentile, and apply those Vmin and Vmax values automatically. So we can also do the same here. We don't want to figure out the min and max. We can just say robust equals to true. And now we have this nice looking visualization of the satellite image at a location. If you run the entire code, it takes probably less than 2 minutes. So in 2 minutes, you can now get a median composite anywhere in the world. And that's a kind of refreshing change for people working with remote sensing data, where you don't have to download, process, wait for hours to do the process. You can stream the data, use libraries like XArray to do this temporal compositing very, very easily and show the result.
Yeah, so for the exercise, we want to create a median composite for the month of May. So we have in our data set, we have data for the whole year. And the first step is to aggregate it by a month. And here that step is covered. You see that we are having data for months, and your task is to select data for the month of May using EL cell operator function that we have. You can select using the month attribute, and then you can go ahead and create the median composite and plot it.
Yeah, so you can see here the syntax for aggregating data is similar to pandas. In pandas, if you want to do group statistics, you will just say group by. And here you can just group by any dimension. So here we are saying group by time, but not if you just say group by time, it's just going to go through the entire year. We say group by time dot month. And XArray provides you with this time primitives, which you can use. They are well documented. So time dot month will aggregate by time and so on, aggregate by month. So what the ts dot group by time dot month will create 12 groups of images for each month. And then we can say for each of those groups, give me median across time. And now this one line of code has created 12 images, median composite for each month. So you should get 12 images with 12 time steps. Here in the screen, you can see the region that Vigna has chosen did not have any cloud-free images for some of the months. So she got only 10 images. So you can see you have month 10. So there are 10 time steps per month. Many of you will get all 12 months. You can see in the month, you have 1, 2, 3, 4, 5, 6, 9, 10, 11, 12 for a case. So we have 10 monthly images. Other 2 months didn't have any cloud-free images, so you didn't get anything. Here, your exercise is to extract the image for the month of May, which is month 5, and plot that. In case you don't have any images for month 5 in your region, plot one of those. The idea is how to use the cell function to select one of the months and plot that.